Hi guys, so in section 1.3 we're going to cover real numbers and the number line, and what we're working on doing today is we're going to introduce the operations of the square root as the inverse operation of squaring. So what I mean by that, right, a square root, so a is going to be the square root of b if a squared equals b. So in this, with this idea, we're going to say that if 4 squared is 16, then 4 must be the square root of 16. So take a second to define these terms using your book, the radicand, the radical, and the perfect square. So you can pause, go look at your book, get that stuff in your notes. But we are going to work with this idea here where we have the square root sign and then a, right? So this right here, that's the radical symbol. Radical symbol and the radicand, okay? So if we use that terminology, that should help a little bit. Okay, so let's try these examples right here. So in example 1, it's simplifying square root expressions. So we want to find the most simplified form of each expression. So when we're looking at the square root of 81, we want to think, how can you find a square root, right? Or find a number that we can multiply by itself to get a product that's equal to the radicand. So basically I'm asking myself, what times what gives me 81? And hopefully you remember that that is 9, right? Because if I did 9 squared, I'd get 81. So my answer must be 9. The next one's a little bit tricky, right? If I want to say, what times what equals 9 over 16? Well, if I look on the top here and I say what times what is 9, I would say that that's 3, right? Because it has to be the same number. And then when I look on the bottom, what times what 16, I should get 4, right? So that means that my square root of 9 over 16 is going to be 3/4, right? Because 3/4 times 3/4 equals 9 over 16. So take a second, pause the video, and try A, B, C, and D. Okay, so when you're looking at A, hopefully that you see that if you're looking at what number times itself is 64, hopefully you'd get 8, right? Because 8 squared is 64. 8 times 8 is 64. When I'm looking at square root of 25, you should get 5, right? Because 5 squared is 25. And this one, remember fractions can be a little trickier, but what times what equals 1 over 36? Well, 1 times 1 is the only thing that equals 1, and then 6 times 6 is 36. So my answer here would be 1/6. Make sure you're keeping these in fractions, like I said. The last one right here. So, sorry about that. Remember, I'm thinking, what times what equals 81 over 121. Well, what number times itself is 81? Here we know it's 9. 9 times 9 is 81. And then if I'm trying to think of what times what is 121, well, we know it's going to be bigger than 9, right? Because 9 times 9 is 81. And hopefully you'd get to 11 even if it took a little bit of trial and error. And then I would get my answer to be 9/11ths. All right, so you'll want to pause this and then get this written down. But in problem 2, we're going to look at this word problem. It says, lobster eyes are made of tiny square regions. Under a microscope, the surface of the eye looks like graph paper. A scientist measures the area of one of the squares to be 386 square microns. What's the approximate side length of the square to the nearest micron? So there's 2 different ways that we can do this, right? We want to find that what's the approximate side length. So if we know that the area of one of the squares, so here's a square, right? And remember, oops, you probably did a side length. The area of a square would be the side squared, right? Or S times S. So here it says the area of one of those squares is 386. So that must be S squared, right? So what times what equals 386? And this is where it can get a little bit tricky, right? So 2 methods. First method, estimating. So if I was doing squares, I might do like try 18 times 18, try 19 times 19. If I get 19 squared, I see that that's 361. That's pretty close, and you can use your calculator to find these perfect squares. But then if I do 20 squared, I get 400. So 386 falls somewhere in between there. So, but a little bit closer to this one, right? When I'm just thinking about where that stands. So I could say that the square root of 386 is close to, I don't know, maybe I'd say 19.5. 20 would work too for that as an estimation. Your other method here is to obviously use a calculator. And if you did that, you would get about 19.6 for your answer. Okay, so you will be able to use a calculator for some things, but not all of them. When we're on some of the tests, you'll have a no calculator. Most of the ones, if you do them at home, that you will have a calculator available for you for that. Okay, you should also use your book now to define these. So define set, element of the set, subset, rational number, natural number, whole number, integer, irrational number, and real numbers. You'll find most of these on page 17 and 18 of your textbook. And pause it and come back after you're done. Okay, so your book has this nice little concept summary that shows you examples of rational numbers, integers, whole numbers, natural numbers, and irrational numbers. And we're going to use it to define these subsets. So if I want to define 15 in A, we would define that as a natural number, right? But it's also a whole number, an integer, and a rational number, right? A rational number is any number you can write in the form of A over B. So even though it doesn't seem intuitive necessarily, you can write that as 15 over 1. That's the same thing. So if it's a rational number, right, this is all encompassing all of these things. So any rational number is also an integer whole number, or sorry, I'm saying that wrong. If it's a natural number, right, so like 15 would be a natural number like 7 here, then it's also a whole number, an integer, and a rational number, right, because that box falls inside of there. Now if I look at negative 1.7583, first let's look, is it irrational or is it rational? Well, an irrational number cannot be represented as a quotient of the two numbers, which means that it is not a terminating decimal, or the decimal never ends, but this one does end, so it's going to be a rational number. But is it an integer, right? We want to see if it's an integer, and it's not, right, because an integer lands on the number line, and this does not, since it's between the two things. So this one would just be a rational number. And then the square root of 57, right? If you type that in your calculator, you'd see that that decimal place goes on and on and on and on. So that's an irrational number when we're defining that. So go ahead and try these ones here. Okay, so once you've paused it and you took a minute to try those yourself, A, you should have got to be natural, whole, integer, and rational. B, you should have got rational. C, you should have got irrational. And D, you should have got as an irrational number. Okay, so let me move this. The rest of your assignment for notes, and this I will check, is to, on page 19, take notes on that page. It goes over inequalities and comparing numbers. I want you to write everything you can, and I'm going to come in and I'm going to ask you guys questions about that page and what you understood there. So finish out the notes on your own using your textbook for this section.